Right triangle trigonometry. All right. So we're going to define each of the trig functions. So we're going to start getting into the actual pre-cal stuff, or a little more today. Definition. Well, definitions of the 6 trig functions of acute angles. So the 6 ratios of the length of a right triangle are called trig functions. So that's basically what they are. And the sine function, sine of an angle theta, we write this way, sine theta, which is equal to the opposite side over the hypotenuse. Okay, so given some triangle and draw it over here, if I put theta right there, opposite hypotenuse, the adjacent side. Cosine of an angle theta, written this way, cos theta is equal to adjacent over hypotenuse. Tangent of theta is written as tan theta equal to opposite over adjacent. Okay. The easy way that we try to remember is the phrase SOHCAHTOA. So S would be sine, C would be cosine, T would be tangent. So sine, S, is opposite hypotenuse, C, adjacent hypotenuse, TOA, T, opposite adjacent. So that's usually an easy way to remember. Okay, now the other 3 functions are going to be based off those original 3. They're just reciprocals. So cosecant, I guess we'll write the word again, consistency. Cosecant of theta is written as CSC theta, which is the reciprocal of sine. So hypotenuse over the opposite. Okay. Secant of theta, or SEC theta, is equal to hypotenuse over adjacent. So this is the reciprocal of cosine. Cotangent of theta is written as just COT theta. That will be the reciprocal of tangent, which is adjacent over opposite. It's all based on the triangle. All right, reciprocal properties. I'm gonna give you all the formulas before we start. Reciprocal identities. So first one, number one, cosecant theta is equal to 1 over sine theta. Number two, secant theta is equal to 1 over cosine theta. Number three, cotangent theta is equal to 1 over tan. That's why these are the reciprocals. Quotient identities. Number one, there's tangent theta is equal to sine theta over cosine. Number two, cotangent theta is equal to cosine theta over sine theta. And I'll write the next set of formulas on the next page in just a moment. Okay. It's cool on this page. No rush. Just let me know if you need to look at something. Pythagorean identities. So there's really only, well, they all come from the original. This is the main one right here. Sine squared theta plus cosine squared theta is equal to 1. So now if you just do some algebra, you can create two more really easily. Say you subtract cosine over here, you're going to get sine squared theta equal to 1 minus cosine squared theta. Subtract the sine. you get cosine equal to 1 minus sine squared theta. Is that clear? But subtract cosine on both sides, and you get this. Subtract sine on both sides, you get this. Okay, so so now there's two other sets of 3 by doing division. So that was just subtraction. So if I take this first equation here and divide by sine on every single term, sine squared divided by sine is 1. Cosine squared divided by sine squared is a cotangent. 1 divided by sine is this. Okay, which is actually cosecant. Once you create this, you just subtract things around and you make some more. Cotangent squared theta is equal to cosecant squared theta minus 1. Subtract cotangent and you get 1 equal to cosecant squared theta minus cotangent squared theta. That looks a little messy there. Okay, any questions on where this came from right here? Okay, well, let me know. Now you take the original again, like I did here, divide every single term by cosine. So you're gonna get tangent squared theta plus 1 equal to secant. Subtract the 1 over, you get secant squared theta minus 1. Subtract the tangent and you get secant squared theta minus tangent squared theta. So this came from, you divide the original by cosine squared. Okay, so that's all the formulas for this section. Let's get started. If you have any questions, let me know. So find the value of the 6 trig functions. Of the angle theta in this figure. Okay, so the homework's gonna do something like this. I'm gonna give you some triangle. Here's theta. Here's 9, 40, 41. Okay, one moment. All right, so they want us to find the 6 trig functions. So I recommend you start with finding sine, cosine, etc. But let's say they didn't give us this piece, right? Because on the homework, they're only going to give you 2 sides at most. So you're going to have to use Pythagorean. So let's just pretend they said, figure it out. So Pythagorean theorem says the leg squared, the sum of the leg squared is equal to the hypotenuse squared, right? A squared plus B squared equals C squared. So we can solve for C. So plug in the 9, plug in the 40 equal to C squared. So C will equal the square root of 9 squared plus 40 squared. I skipped an algebra step here. You guys okay with that? When I got from here to here? You got to square root both sides to solve for C, right? So at this point, punch it into your machine. That should be, I believe that's going to be 41, which is what we had earlier. Okay, so that's probably how it's going to start. They might be missing a leg or you know, maybe the hypotenuse. You just got to solve for the appropriate variable. Okay, so let's answer the question. It wants us to find sine theta, which is opposite over hypotenuse, and that's right here. So it's always opposite to the theta they're talking about. So if theta is up here, opposite's down here. Theta is right there, so it opposite is 40. The hypotenuse is always the hypotenuse. Cosine is adjacent to theta. Cosine of theta, whatever angle they're talking about, adjacent to that angle. So that'll be 9 over 41. Oops, I should put the formula. It'll be adjacent over hypotenuse. Tangent is equal to opposite over adjacent, which is yeah, I don't think I have space. That's fine. I'll just, sorry, I guess I'm a little distracted today. Adjacent being 9, hypotenuse being 41. Just go ahead and do a tangent right here. Let's make some space here. Tangent theta is equal to opposite over adjacent, which will be 40 over 9. And you just look at the triangle. 40 over 9. The sine, cosine, tangent. Okay. So now we just need the reciprocals, right? Which aren't that difficult. You can either use definition or the reciprocals. So cosecant theta is the reciprocal of sine, so just flip it over. Right? Secant theta is the reciprocal of cosine, so flip that over. Cotangent is reciprocal of tangent, flip that guy over. So here are the solutions. I guess I should just box the whole thing. Pen's running out. Anyway, any questions on this problem here? So given a triangle, can you find the okay. Let me know. Let's do something similar. Let me go ahead and open the homework. Okay, there you go. Trying to shorten up the homework for you. So you also have examples like this where they give you one trig function. So given secant theta is equal to 12, find sine theta, cosine theta, tangent theta. So you have to basically build the triangle. So we know that secant theta is equal to hypotenuse over adjacent, right? Because it's the reciprocal of cosine. So that means that this is equal to 12 over 1. So any number can be written over 1, right? Because it's equal to 12 divided by 1 is 12. So you can always do this. And we force it because we need that piece for the triangle. So the triangle, if I choose to put theta here, hypotenuse is 12, adjacent is 1, right? Does this first step make sense? Or is that clear? Okay, all right. Well, let me know. So we need to find sine. That's opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And tangent will be opposite over adjacent. So that sine is going to be, shoot, I need the opposite side, right? So we're going to have to do Pythagorean theorem. So a squared plus b squared equals c squared. So it's my little scratch work over here. If I call this a, I need to find b. So solve for b. That'll be c squared minus a squared. Square root both sides. B will be the square root of c squared minus a, which is the square root of 12 squared minus 1, which is 143. So this ugly number, 143. So I forgot I needed to first find the missing side using Pythagorean theorem. You guys remember the Pythagorean theorem steps? Now, if you have all three sides, all three sides of the triangle, you just pretty much plug them in, right? Opposite over hypotenuse. So that's the sign right there. Cosine will be adjacent over hypotenuse. There's cosine. Tangent will be opposite over hypotenuse. Any questions on example 2?
Will we just always put it over 1 like that if we don't know?
Yeah, if you're giving like a solid number and you need it needs to be a ratio, you can always change it. Any number can be written like that, as well as variables.
Okay.
Alrighty. Let me see where we are on the schedule real quick. Oh, looks like we're doing good. Cool. All right. Let's keep going. Let's do one more. Let's see. Let's do one more of those and then we'll move on. Something different. Example 3. This time I'm going to give you sine theta equal to square root 3 over 4. Find all 6 trig functions. So sine theta is equal to opposite over hypotenuse. Well, actually, before we do that, let's draw our triangle. We need all 3 sides to solve the question, right? So we are given sine theta equal to, right, I'm going to write them down here. Which is equal to square root 3 over 4. So opposite 4. Now use Pythagorean theorem to find that missing side. So that will be square root 3. Solve for b. So b squared will be equal to 16 minus 3. So b is equal to square root, what is that? 13. I did the Pythagorean part a little quickly. Is that okay with you guys? You comfortable finding A, B's, and C's? Okay. Cosine theta is equal to the adjacent over hypotenuse, which is equal to square root 13 over 4. Tangent is opposite over adjacent, so that will be root 3 over root 13. Okay. So now just take the reciprocals and you'll find the, it's kind of messy. Let me just write it at the bottom. I'm just rewriting it. I'm not changing anything. We said root 13 over 4. So tangent theta is equal to opposite over adjacent, which is this here. Okay, so reciprocals, pretty easy, right? Reciprocal of sine would be cosecant theta, which is equal to 4 over root 3. Reciprocal of cosine is the secant, so 4 over root 13. Cotangent theta is equal to root 13 over root 3. Now, they may ask you to rationalize when you have roots on the bottom. They might accept it this way. It depends. So if they don't, please rationalize. Do you remember how to rationalize? Okay, so if you have a square root in the bottom, you multiply the top and bottom by the square root in order to rationalize. So you just do this, multiplying by root 3, which gives us 4 root 3 over 3. This is 4 over root 13 times root 13 over root 13, giving us 4 root 13 over 13. So what happens is when you multiply by this form of 1, it squares the bottom basically and forces it to be just a regular number, no more square roots. Root 3 cancel this root 3, give me a regular 3, because that would be square root of 9, which is 3. Same thing for cotan. I'm gonna try to make a little space here. Divider. So that'll be square root of 39 over 3. Any questions on rationalization? So whatever's down here, whatever square root's down here, you multiply top and bottom in order to cancel the root on the bottom. Okay. So let's move on to something else. You guys cool on this example or this page? Right. Let me mention the fundamental identities. And or the complementary theorem. Let's do the complementary first. Complementary theorem. It's going to be, so the first one is that sine of theta is equal to cosine of 90 degrees minus theta. Cosine theta is equal to sine of 90 minus theta. Okay. Which means you can switch back and forth depending on what you need using the given theta. What number are we on? 4. Okay. Cosine of 86 degrees over sine of 4 degrees. So this is supposed to cancel into 1. So what you can use is one of these properties, make them both into sine or cosine. Notice how sine 86 and cosine 86 and sine 4 are complementary angles, right? Complementary meaning that these add up to 90. You guys remember? So that means that we can shift either one. I'm going to choose to shift the sine into a cosine. And the formula says you take 90 and subtract whatever angle that you had there. So that gives me cosine of 86 over cosine of 86. Are there any questions on how we use that formula or why it's 1?
Will it always add up to 90?
You can change that anytime you want. You just so the formula is saying you can shift cosine to sine whenever the hell you want. The theta right here is whatever you're given. So this is built in, the 90. So theta is what you're given. But you only want to do this if it's helpful. Here it turned out to be helpful because the original was already complementary. So switching over lets you cancel. Okay, and let's do one more. One minus cosine squared of 38 degrees minus cosine squared of 52 degrees. So notice how this is another complementary set of angles, right? 38 and 52. That's the hint that we should use the complementary theorem. So I'm going to change them both into, well, actually, I'm going to change the cosine into a sine. So this will be 1 minus sine squared of 90 degrees minus 38 degrees minus cosine squared of 52 degrees. So from here to here, I used this formula, right? 38 is equal to sine squared of 90 minus 38, which is going to give me 1 minus sine squared of 52. So it'll be 1 minus, subtract the minus, be sine squared 52 plus cosine squared 52. Now, if you factor a negative, what do you notice? What property is this? Sine squared plus cosine squared. Okay. So this is going to become 1. Here I just factored -1. Here we use the Pythagorean identity. So this is actually just 0 this entire time. Any questions on example 5?
How did you get 1?
This one right here?
Yep, from there to there, from above that to that, yes.
Okay, yeah, this is the Pythagorean identity that says sine squared of any angle plus cosine squared of any angle. As long as they're the same angle, it will be equal to 1. Just the formula. So as soon as I force them to be the same angle using the complementary angles, this turned into a 1, which then canceled the original 1.
Okay.
So the whole point was, okay, how can I simplify this? In the homework, they're just going to ask you simplify or use your complementary / whatever property. So I changed the cosine into a sine, and then once I saw that they were the same, I set it up for this guy. Okay. Any other questions on number 5? We're going to move on to 7.3.
Oh wait, can I have a second to finish writing this down?
Yeah. No rush. We have plenty of time. We're only going to do one more section, and then we'll see if you guys have any homework problems or any issues. You guys cool on this page? Good. So 7.2, we talked about, let's go over one real quick, or 6.2, sorry. Definition of sine, cosine, tangent, cosecant, secant, cotangent, reciprocal, quotient identities. So I give you all those properties just in case you need them. We'll be using them, throughout the semester. And then we use the complementary theorem. Computing the values of trigonometric functions of acute angles. Okay. So for this entire section, all you're going to need is the unit circle, at least for these next few examples. Do you guys still have it? I'll throw it in the chat in case you don't. But if you do, just open it up. So a quick rundown on how to use it, just in case. So the x values will pertain to cosine, all the x values. So if I say cosine of 30 degrees, you would give me an output of square root 3 over 2. If you say sine of 30, then you would say, and that output is 1/2. So all around the circle, sine is y, cosine is x. Okay. Tangent is sine over cosine, so you would divide the y by the x if you did tangent of 60. Is there any question on how to read the circle? What is the x and what is the y? Is that clear?
You said tan is y over x?
Yes. If you remember the definitions, you'll just use them accordingly. But we're going to do examples in just a moment. One second. Actually, that's fine. Compute the values of the trig functions. So A, sine of 60 degrees. So what is that answer on your circle? Let's look it up. So all these first few questions, all they're going to ask for is what is the value on the circle? So sine of 60 is right there. The y value is square root 3 over 2. So that's all you're going to put in your homework, square root 3 over 2. Now, if you're wondering what the heck these values mean, they're found by building triangles by using this angle and this sine as your hypotenuse, coming down for your opposite side and then your adjacent side. Solving for those pieces will give you this. So you just keep building triangles. Go here and drop down, go here and drop down. You create triangles all the way, everywhere. But I'm not going to make you memorize the circle, but I do expect you to know how to use it right away. So cosine of 60 would simply be the x value. Okay, so just a quick note, cosine theta is equal to the x value on the unit circle. Sine theta is equal to the y value on the unit circle. Shouldn't be too crazy to use that. Okay, so homework will start off with stuff like this, and then they'll move on to something a little more difficult. Say find 4 cosine of 30 degrees minus 6 sine of 30 degrees. So use your circle. This will be 4 times cosine of 30 is going to be square root 3 over 2 from your circle, minus 6 times 1/2, which will be, reduce it. This would be 2 root 3 minus half of 6 is 3. Any questions on how we did this or where the values came from? Now, they're not always going to be in degrees. They may be in radians, which are also on there. So the next one, let's do radians. You guys cool on 1 and 2 so far? Okay. So secant of pi over 4. So this time, it's not one of the basic questions. Plus 13 cosecant of pi over 6. Now, remember that secant is defined as the reciprocal of cosine. So you can just switch it to this and then use your circle straight up. So plus 13 over sine over cosine. We said sine. Okay. So cosine of pi over 4, let's go look at the circle. Pi over 4 is the same as 45 degrees. Cosine is square root 2 over 2. Sine of pi over 6 is going to be square root 3 over 2. So those are the answers I'm going to use. So square root 2 over 2 goes right there. Plus 13 over we said 1 square root 3, right? Yeah. So just plug them in from the circle. And now we just got to do a little algebra. 1 over that, we'll flip it over to 2 over, excuse me. Sorry, to sneeze. 2 over square root 2. Pen's dying here. Plus, flip that over, that'll be the same as saying 13 over 1 times 2 over root 3. Okay. Rationalize this guy. Multiply. So this would be 2 root 2 over 2 plus 26 over root 3. Rationalize this guy. And we are done. If you don't rationalize it on the test, I'm not gonna give you crap about it. But the homework might request it or require it. But I'm not gonna take points for something like that. But you should know how to rationalize, right? Shoot, I think I made a mistake. Let's look at the circle again. Sine of pi over 6 is 1/2, not root 3 over 2. Let me fix this. So this part right here is messed up. Sorry about that. This part's good. So this will be 1/2 right there, which will flip over and give you 13 over 1 times 2 over 1, which will give me 26. So rationalize that guy. These cancel, giving me root 2 plus 26. This is the answer. Any questions about any of those steps? Okay. All right, you guys are good on this page? Let me know. Okay. The next couple of examples are about functional algebra. So I'm going to go over it real quick just in case you forgot what that is. This is what you need to remember. So this is from college algebra. When you add two functions, this notation, at least that's what the notation means. If you have f plus g of x, that means add f and x. If you have fog, you guys remember this, right? F composed with g, that's going to be f of g of x. And if you have it the other way around, you just switch. F goes inside G, and if it's this way, G goes inside F. Okay. So for example, it's a quick algebra example, side example. If F of X is equal to, let's say, X plus 3, and G is equal to X squared, then F of G would be equal to F of G of X, which is equal to F of X squared. So the G goes inside the F. So then you input this over here. So that'd be X squared plus 3. Okay. So that was a quick reminder. What does the symbols mean? I don't want to spend too much time on it because you had a whole class on that. So they're going to bring this up on examples like this. I might have to change pens. Yeah. This is dead. All right. F is equal to sine X. G is equal to, let's say, cosine. So if they tell you, what number are we on? Example number 4. Example 4, find the value of F plus G of 60 degrees. So all that means is find F of 60 plus G of 60, which is equal to sine of 60 plus cosine of 60. So that would be, look at your unit circle, sine of 60 is going to be the y value. So that would be root 3/2, right? Plus 1/2. If you combine the fractions as far as you can go, root 3 plus 1/2. So if they throw this type of symbols at you, don't let it mess with you. It's you're just adding two things together. Who cares? Okay. Is there any questions on example 4? Okay. The next one is a composition type. let's say f of x equal cosecant and h of x equal 2x. Find f of h of pi over 6. So the notation means f of h of pi over 6 which means f of, and h is right there, right? So that'll be 2 times pi over 6, which is f of pi over 3. Then plug this guy into the actual f, cosecant of pi over 3. Okay. So we're just doing a composition. Goes into the h first. H simplifies it, goes into the f. Here's the f. This is actually the same as 1 over sine of pi thirds. So this would become 1 over pi thirds is, let's look at the circle. Pi thirds sine is the square root 3 over 2. So square root 3 over 2, which will be 2 over root 3. Rationalize this guy if you want to, or we need to. You will get this. Oops. Damn it. All right. Let's do a word problem, maybe 2 of them. And then we'll call it a day. And we'll see if you guys have any homework problems. You guys cool on this page? We are on number 6. So a right triangle has a hypotenuse of length 4 inches if one angle is 44 degrees, find the length of each leg. Okay. So of course it's a right triangle, so we have that side. They told us that one of the angles is 44, so I'm going to call this one 44, just because they didn't specify which, so we'll choose that guy. They said the hypotenuse was 4 inches, right? That's all the info we got. They want us to find the missing legs. So we can use any trig function that incorporates a hypotenuse to help us solve the missing sides, okay? So I'm going to use sine of the 44 degrees, sine of this thing. That's equal to the opposite side, which is unknown, over the hypotenuse. So multiply both sides by 4. That would give me 4 sine 44 degrees in inches equal to the opposite side. So what would that be? Let's pull out a calculator. So in this section, you will need some, at least a scientific. Okay, so 4 sine 44 is what we're going to do. So 4 sine 44. Let's check if we are in degrees, and we are not. You should get 2.77. So let's round to 2 decimal places. The opposite side is 2.78. I don't know why I spaced it like that. 2.78 inches. 2.78 inches. So now I have 2 sides. So we can use Pythagorean theorem, or you can use another trig function. It doesn't really matter. We do Pythagorean, we know that a squared plus b squared equals c squared. So let's solve for a squared. So subtract the b, square root both sides, gives me this garbage. So now plug in the numbers, that would be the square root of 4 squared inches plus 2.78 inches. So that'll be 16 plus 2 point, well, at this point, I would just say use a calculator. There's no reason to do that. Because we got decimals going on. Decimals, sorry. So approximate with your calculator. This will be approximately something. So the square root 4 squared plus 2.78 squared. So 4.87 inches. Double check that. Yeah, that's right. All right, you guys cool on this first word problem then? let's do another one. This one was had a nice, pretty picture, but you'll see it on your homework when you get there. Example 7. It's the last example for today. Find the distance from A to C across a gorge. Okay, so basically, okay, let me actually, it might be better to find, well, 1 second. Maybe I could just draw it. Okay, yeah, here it is. So picture some river in the middle here. This, maybe a little bigger river. Right, so right there. So you have this triangle. You're on this side over here. This is my point A. This is my point C. They want to know how far is it to cross from A to C, right? And they gave me an angle of 40 degrees here. So you can walk across over here and figure out the angle yourself, right, in real life. And then you can calculate how far it is across without measuring, because you have pre-cal. So we can use tangent to help us out because we have one of the sides and we need the opposite side. So tangent is equal to the opposite over adjacent. And we currently have tangent 40 degrees equal to opposite over 90. So opposite is equal to 90 tangent 40 degrees, right? Just multiply 90 over here. You'll get opposite by itself. Punch this into your machine and you will get the distance across the gorge. Ninety, 10, 40. So that is about 75.52 feet. Is there any questions on why I chose tangent or the algebra along the way? Okay, we have about 20 minutes still. You guys have any homework problems you're struggling with or you feel are ridiculous and I should delete? Either way, let me know. I try to get rid of the crazy ones if I see one. Any questions on the first topics? I know that one's a little difficult. All right, guys. If you don't have questions, I'm just gonna go get pizza and chill. So it's on you.
I'm doing the same thing. Where are you getting pizza from?
Probably by Papa John's.
Hey man, Barbaro over there off of McCullough has $10 pizzas tonight. If you've ever been over there, they're doing their $10 deal and it's takeout. So you know, that's where I'm headed.
Barbaro's?
Anyway, thank you very much.
All right, I'll check it out. Thanks, man.
Informative class. Appreciate you. Have a good night.
Take care.
You too.